All right. Well, happy Friday. It is week 3 Friday, and that means after today we're like 30% of the way through the quarter, which it seems like we just started, or I don't know, maybe it feels like it's already been a long 3 weeks, now that you've submitted 2 homework assignments and things like that. But, all right, well, I have posted, I know, it's just like as soon as there's no rest for the weary. I have posted homework 3. Homework 3 will be due February 8th, okay? So 1 week from today is February 3rd, and then it's the following Wednesday, February 8th. So that's when homework 3 will be due. Now, depending on what kind of student you are, some will be like, oh, homework 3, let's open it right away, and we're gonna look at it this weekend. And some of you won't open it until like February 6th, but hopefully most of you will open it before then. Regarding homework 3, though, there is a lot of stuff we haven't covered yet, okay? So homework 3 uses dplyr, and we'll use regular expressions, and we're going to cover that next week. But I did want to kind of post it. Part 3 of homework 3 does web scraping, okay? So part of your assignment in homework 3 is web scraping, and you're going to go to this baseball reference website, and you're going to download some data, and you're going to kind of open up a session and navigate through the pages to download information from each of the different pages. I tried this out. I tried out my solution and stuff, and again, like I've said, there's a little bit of an arms race between running bots and scraping data, and servers kind of managing how many hits they get. And so for this homework, you will most likely have to use a Polite session. And so you're going to have to download and install Polite and create a Polite session that will crawl through the pages a little bit more slowly and politely as it does that. Because I tried my older solution, which was not Polite, and when I tried to run it, my IP got rate limited, which basically says, anytime you make a request to the thing, even if I tried it in my browser, I got this error from Cloudflare that says you're making too many requests. Come back in an hour. So basically, I don't want that to happen to you guys, all right? So, or actually, you won't be able to do the homework unless you use the Polite session. So I've updated in week 3 the arvesdemo.r code. I think last time I showed this to you, I did have a Polite session going, but I added additional commentary in the comments on kind of how the Polite session works. And so hopefully you'll be able to use that as kind of a starting point and a model for how to go about visiting another page, scraping its data, extracting out the content and things. You'll still use selector gadget to highlight the name of the teams, to kind of extract out those bits of information, the URLs that you're going to go to, and use that to power your web scraping. But anyway, that's there, and if you want to kind of just dip your toe in the water with web scraping, you can probably get started this weekend if that's something you want to do, or you can wait later on till next week or something to try it out. But that's what we have. Okay, let's look at today's stuff. And today's lecture I've titled Tidy Data. And we are going to start introducing the tidyverse, and we're going to use several packages from the tidyverse. Today we are going to look at tidyr. And so some of you had Stats 20 with Professor Tseng, some of you had Stats 20 with Professor Liu, and depending on who you had Stats 20 with, you may or may not have had very much exposure to the tidyverse. And so we're going to kind of cover some of this stuff. I don't know, was tidyr covered in Stats 20 for any of you? tidyr? Okay, no. But maybe ggplot? Yeah? Okay, some of you are nodding your head. Okay, well anyway, a lot of this stuff comes from this textbook, R for Data Science, and this one is free to read in your browser. And again, if you want to pay and get a physical textbook, that will be that you can do that, right? Oh, and it looks like it says work in progress for the second edition. Oh, let's look at that. This is the work in progress second edition book. Okay, well that's exciting. That's coming out later this year, I guess. But well, anyway, this is what we have. Okay, so today we are looking at tidyr, R for Data Science, and the tidyverse is a collection of packages, and so now this is quote unlocked for you guys. See, so now that I've mentioned the tidyverse, you can start using tidyverse in your future homeworks, and you'll definitely need to use it for homework 3. And so when you load up library tidyverse, it's going to load up some packages. Some of these are very well known. Some of you have already used things like ggplot, dplyr. We've already mentioned readr, and in our course today we'll look at tidyr. We'll also later on we'll look at stringr and dplyr and things like that. And then I guess we'll also look at Tibble. But there's other things that the tidyverse employs. Okay. So first, let's talk about Tibbles. Tibbles is the data structure that the tidyverse uses. Tibbles are basically the same thing as data frames. Okay, data frames we know are internally stored as lists. They're arranged in this two-dimensional matrix structure, so you have columns and things like that. Okay, and the Tibble has kind of just taken the data frame and just upgraded it a little bit, added a few nice features that are nice for that make it nice for us when we work with a data frame. Okay, so here is just an example Tibble that I've made up, or actually I've copied this from the R for Data Science, I think, website. And here we're going to have 5 columns. The columns are A, B, C, D, and E. Again, terrible names for columns in real life. You want to have your names represent something, but these columns don't actually represent anything. So we got A, B, C, D, and E. One will contain time data, one will contain date data, one contains just some integers, another contains some random uniform values, and another contains some characters, random letters, okay? And one nice thing about Tibble is that when you print a Tibble, it is aware of your screen size, and it tries to only print content that will fit on your screen. So it kind of interacts back and forth with RStudio and says, hey, you know what, how big is their screen and how much can I fit? And it only tries to fit the amount of data that will show up on the screen. It only generally prints the first 10 rows. I don't know if you've had the experience where you're working with a data frame and you kind of want to look at your data frame, so you type in the name of your data frame into R, and then it turns out this data frame is massive, and it like suddenly, like, to see your previews come in, you have to scroll up like multiple pages because there's just like so many columns and so many rows that just got kind of printed out. And so so that doesn't happen when you use a Tibble. Okay, with a Tibble, you only get basically the first 10 rows and whatever columns fit on the screen. Another thing about Tibbles is that when you subset a Tibble with single square brackets, what a Tibble will return will always be a Tibble. So when you subset a Tibble with single square brackets, it will always return a Tibble. This is different from a data frame, where if you recall the subsetting of a data frame, there's different behaviors. So if we take a data frame, and I've got a data frame with column X and column Y, and I subset with single square brackets, and I say I just want the first column, what does it return? It simplifies it down to a vector, and it gives me the values 1, 2, 3, rather than a data frame with one column. Okay, or if I do, but if I took a data frame and I subset to the first row would actually retain the data frame structure. Okay, but if you subset to the first column, it simplifies to a vector. With a Tibble, if you say I only want the first column, so here I've got a Tibble with column X which is 1, 2, 3, and column Y, which is 3, 2, 1. And if I say I only want the first column, it's going to return a tibble with one column here. Okay, so that may or may not be what you want. Okay, but that is something to kind of keep in mind, is that when you use a single square bracket with tibble, it's always going to return a tibble, and you don't have to kind of keep track. Am I subsetting a row? Am I subsetting a column? Is this going to simplify down to a vector? Is this going to retain its data frame structure? If you do want to simplify it down to a vector, that is still an option. You just have to explicitly tell it, and you put in the optional argument drop equals true. So it is possible to simplify it down to vector. You just have to explicitly say so. Whereas, data frames, it will simplify down, which can get a tiny bit confusing if you're not paying attention all the time. All right, to create a tibble, you just use a function tibble, and then you specify the names of your columns, equal, and then the content of each of those columns. So again, just a random tibble with columns A, B, and C. A is just a random five values. B is going to be 5 random letters, and C will be 5 random normal values. Okay, and that will create a tibble, 3 columns, 5 rows. You can also just take an existing data frame and wrap it in the function tibble. Okay, and so you can just take it. So here's data frame empty cars. You wrap it in tibble, and that turns the data frame into a tibble. And one more way of creating a tibble. Sometimes, I would say this is not very common, because most of the time when you're dealing with data, you're going to just read in a CSV file from somewhere else. But sometimes you want to type in the data yourself, and you can do that. And a lot of times, it's easier for us to think of data in rows, right? That's often how our brain thinks about data. And so here, if you wanted to create a small data frame, a small tibble, where the first entry is the letter A and the number 1, second row is the letter B and the number 2, and the third row is the letter C and the number 3, you can do this. You can kind of go A, comma 1, comma B, comma 2, comma C, comma 3, so I'm filling out the data row-wise, okay? And so this is a little bit contrary to R's normal column-wise operations. And we say, okay, I want a tibble, but I'm doing it row-wise, so this is the tribble, okay? You have an R in the tibble there, okay? And this will create the tibble row-wise, right? Column names are preceded by the tilde, and that's how you do that, okay? And that's how we make tibbles, and they are handy, and we're going to use them. Okay, let me give you your first view quiz answer. First view quiz answer today is the letter E. E as in elephant. E as in elephant is our first view quiz answer for today. Okay, today's lecture is going to focus on this concept of pivoting data to make our data tidy. So when we work in the tidyverse, when we work with ggplot and dplyr and things like that, we want our data to have this tidy form, okay? And the philosophy of the tidyverse is that data that is tidy means that basically our data exists in a rectangle. Every column is a variable. Every variable gets its own column. Every row is an observation, and every observation gets its own row, okay? So each row, one observation in the row. You're not going to have a single observation spread across multiple rows. You're not going to have multiple observations within one row type of thing, okay? Every cell is a single value, and kind of going along with all of this would be every table contains only one kind of data, all right? You're not going to be mixing in, person data with school level data or something like that, okay? So we have, here's an example of some tidy data. This is data, I guess, about some tropical storms. And we have, Hurricane Alberto and Alex and Allison and things like that. And what we see is that each row is an observation. Each row is a different storm. And each column is a variable. And so the columns that we have here are things like the storm name, the wind speed, the air pressure, and the date. And so these are all, this is tidy data. One row per observation, one column for each variable, and that's great, okay? Here's an example of data that we might consider not to be tidy, okay? And so here, this is some fictional table about cases of some disease or something. And what do we have? We have information about different countries, France, Germany, and the US. And we have information about the number of cases that happened in different years. So in 2011, 2012, and 2013. And so if we think about what are the variables here, we've got what country did it happen in, okay? When did it happen, the year, and the values are kind of spread around, okay? And they take, the values are found across 3 columns, and the values that we're storing are the counts, right? So these are, this is not this one column business here, right? Here's another example of data that is not tidy. What is the information that we have here? We have the city, all right, and we have 3 cities, New York, London, and Beijing. And we have the particle size, we've got large and small particles, and then we have the amount. So we have large and, amount of large particles, amount of small particles. And so if we think about how is the data stored here, well, one of the variables is city, and so that's in one column here. But one of the other variables is the number of large particles, or the amount of large particles, and the amount of small particles, and those are actually, those numbers exist in the same column. And if we wanted to kind of deal with these separately and just kind of say like, okay, how many more large particles than small particles do we have, right? I would have to do like 23 minus 14, 22 minus 16, 121 minus 56, and that kind of operation would be challenging to do if we wanted to do some kind of comparison like that, okay? The reason why we like tidy data is because we can do these vectorized operations. Okay, this slide is just loading up the data. All right, so the data actually exists online on GitHub, and so I just have the URL of these CSV files, and I'm just doing read_CSV for storms, read_CSV for cases, read_CSV for pollution. And this is also just the output of using read_CSV. It says, okay, these are the kind of the different columns that we've detected, right? We've detected 1 character column, which is the storm name, 2 columns of numbers, which will be the wind and pressure, and 1 column of dates and things like that, right? So it's just telling us the how many columns it detected and what types they are. So when you use read_CSV, it prints out a little summary of what it did. Okay, but again, here is one of the reasons why we like working with tidy data is we can do vectorized operations. So let's say I wanted to do a calculation with the values in our data. So let's say I want to calculate the ratio between the storm's air pressure and the wind speed. So I want to do pressure divided by wind. So this is very simple. I just do storms $pressure divided by storms $wind, okay? In a future lecture, we'll use the function mutate, and I can just do mutate ratio equals pressure divided by wind and things like that. And what R will do is it will vectorize these operations, and it's going to do 1007 divided by 110 and give me 9.15. It'll do 1009 divided by 45 and give me 22.4, and so on and so forth. I don't need to write a for loop that says for each row, do this calculation and put it in there. It's just going to take the entire column, the other column, it's going to automatically line up the data, automatically do all of these calculations for us in vector form. And this is one of the reasons why we like having tidy data, okay? Again, trying to do that kind of calculation here, how many more large particles do we have than small particles? You won't be able to do that, okay? Right? You can't take one column because all the values are in one column. So we want to get our data to be tidy here. Okay, so let's take a look at this cases table. And let's say we wanted to rearrange the data so that we have a column for the country, a column for the year, and a column for the number of cases. So I'm going to, what we're going to call this pivoting the data. We're going to pivot the data. So think about this, right? So if I'm going to rearrange the data so that my new variables will be the country, the year, and the count, okay, I'm going to end up having 3 columns in my resulting table. How many rows? So looking at this, if I take this exact table and I rearrange the data, if I pivot it, how many rows will I end up having? Any takers? You're holding up your fingers? Okay. Yeah, we're going to end up having 9 rows. Okay, we have 9 values here, and they're going to get pivoted into a single column. So here we're going to have, France. France in 2011 had 7,000 cases. Germany in 2011 had 5,800. U.S. in 2011 had 15,000. France in 2012 had this many. Germany in 2012 had this many. And U.S. in this many. Right. So we end up having 9 rows because we have 9 unique values. And then the year values get kind of pivoted into one column, and then our country values get repeated. So when I do this, the function I use is called pivot_longer, pivot longer, okay? Older versions of tidyr called this function gather, and so you might read someone else's code, and they might still use the older name of gather, but it's called pivot longer, okay? And to use pivot longer, we specify which columns want to be pivoted. So we, looking at this, we want to take the columns 2011, 2012, and 2013, and we kind of want to pivot those columns, and that's what we do. The names of those columns get pivoted into one column called year, and the values of those columns will end up getting pivoted into one column called cases. And then the column that I didn't pivot, the country name, gets duplicated. So we get France 2011 7,000, France 2012 6,900, France 2013 7,000, Germany 2011 5,800, Germany 2012 6,000, Germany 2013 6,200, so on and so forth. Okay, so that's what pivot longer does. Okay, a little bit more detail. So this names too. So really, actually, to use pivot longer, you just have to give it the name of the table that you're pivoting and the name of the columns that you're pivoting in. So here, the columns we're pivoting are columns 2011, 2012, and 2013. And I've specified that by just saying 2011 through 2013. I'm also providing it these optional arguments, names to and values to. And here the strings I'm providing are year and cases, but those names are arbitrary. You can choose whatever name you want. So these are bad names. But if I said, hey, I want to call this column when it happened, I could do that, right? And obviously, it's not a good idea to put spaces in your variable names, but if you surround it with backticks, it's technically allowed. And so here I've got the column when it happened. I've got a column how many. And again, there's no kind of semantic meaning behind the column names. It's just whatever you want to call it. If you want to call it variable X and variable Y, you could do that. R is not going to complain, although you'll probably just struggle figuring out what these things mean here. Okay, so the names are arbitrary. Okay, so here is a thought exercise. What happens if I only pivot columns 2012 and 2013? So here I'm going to pivot longer. So here's the same cases table, but rather than pivoting columns 2011, 2012, and 2013, I'm only pivoting columns 2012 and 2013. How many rows will my resulting table have? And what will be the column names of the resulting table? I've got year and cases. So what will the resulting columns be? And how many? Well, first let's talk about how many rows will I have.
6.
I'll have 6 rows, right? Because there's only 6 values between these two columns, so I'm going to have 6 rows. How many columns am I going to have? Yeah, I'm going to have country. I'm also going to have 2011, and then we'll have year and we'll have cases. And this is what the resulting table looks like, okay? So basically, any column that didn't get pivoted gets repeated or duplicated for those things that did get pivoted. So the year and cases, right? So I took 2012 and I got 2013. Those got pivoted, all right? And so those values show up right here, and I got the column, 2012, 2013, 2012, 2013, 2012, 2013. And then, but that column 2011, which did not get pivoted, just gets duplicated, right? So just like the column country name, France got duplicated, France, Germany, US, the column, 2011 gets duplicated, 7,000, 7,000, 50, 100, 50, 100, 15,000, 15,000. So it might feel a little bit strange first, but it only feels strange because, like, in our brain, it made sense to combine 2011, 2012, and 2013. But, if we had a column called capital, right? So we had country, capital, and we had, Paris, Berlin, and Washington or something like that, I think it would make sense to have that kind of information duplicated across the rows. So that's what happens if you pivot only a few of the columns. Okay, here's another question. What would happen if I pivoted all of the columns? So I'm going to say, let's pivot country 2011, 2012, and 2013. So now, again, this feels strange, and this is something we would not want to do normally. But what would happen if I did decide to pivot this country, column country, into our data? Okay. How many rows will I end up having? We're going to end up having 12 rows, and we're only going to have 2 columns. Well, actually, if you try to run this command exactly as it appears, R is going to give you an error, and it's going to say, hey, you know what? Country is character data, and the other values are numeric data, so we can't combine those things. Okay, so I can kind of can't combine country and double. Okay, so I can kind of force it. I can kind of twist its arm and say, hey, make everything character, and then combine it all. All right, and then pivot, and R will allow us to do that. Yeah.
Would there be coercions?
Yeah. So by default, pivot longer is not going to allow you to kind of mix these different types. But if you say, all right, if you coerce everything into character type, and then now all the numbers are actually characters, can we pivot this? Okay, then pivot longer will allow us to do that. So that's what I did here. I kind of turned everything to as character, and then I say I want to pivot all 4 of those columns. And what ends up happening is, that column country, those values just get ended up being pivoted into the same column. So now I have country, France, 2011, 7,000, 2012, 6,900, 2013, 7,000, country DE, 2011. So now I have 12 rows, a column name, a column value, and things like this, right? This is not what we would want to do, but this is what happens. This is just trying to show you what happens when you pivot things, okay? So when you pivot things, it just takes those values and it combines them into one, okay? So that's pivoting things longer. Okay, let's look at this table. This is the pollution table. Let me give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear. B as in bear. Okay, so here is the pollution table. We have 3 columns: city, particle size, amount, and right now I have 6 rows. I've got 2 rows for New York, 2 rows for London, 2 rows for Beijing. Here I want to pivot this the other way, and I want to have basically what? I want to have a row for New York, a row for London, a row for Beijing. So if I do that, how many rows am I going to end up having? How many columns am I going to end up having? What will our resulting data dimensions be? What do you guys think?
3 rows?
3 rows and 3 columns, okay? So we're gonna pivot this way. We're gonna have 1 row for New York, 1 row for London, 1 row for Beijing. We're gonna have a column for city name, a column for the large particles amount, and a column for the small particle amount, okay? The operations that we saw earlier were called pivot longer. Here we're going in the opposite direction, and this operation is called pivot wider, okay? So we're taking our data and we're basically taking the values from one column and we're pivoting those wider to span across multiple columns. And so here I've got the name of the table I'm pivoting, pollution, and we're going to say the names of the new columns come from the old column called size. The values come from the old column called amount. So we look at this, right? So we have size, the names for our columns, large and small, came from that column size. And then the values that fill in those columns come from the column amount. So we're saying names from size, values from amount, right? And there's kind of this inverse operation nature of these things, right? So if you look at pivot longer, the arguments are names to, values to, and here, kind of going in the opposite direction, the arguments are names from, values from. Okay, so again, names from is the name of the columns that will have the names that become the new column headers, and values from is the name of the column that has the values. So let's think about what would happen if our table is not set up 100% correctly. So pivot wider is very sensitive to spelling differences and things like this. And so before you use something like pivot wider, you really want to check and clean your data and make sure everything is the way it should be. So what if in our data, instead of writing New York, somebody had abbreviated it to NYC, okay? Again, you can imagine a data set where you have, information's about the same person, but, in one case, it's like their name is spelled Matthew, and then in another case, their name is written Matt, or something like that, right? And we can imagine stuff like that, and you can imagine, I don't know who calls New York NYC, but it's not that strange either. So what would happen if we take this data and we pivot this wider? So here's my data. I'm going to pivot wider. I'm going to say names from size, values from amount. How many rows am I going to end up having? 4 rows, right? We're going to have a row for NYC, a row for New York, a row for London, a row for Beijing. And what's going to happen to some of these cells, okay? So what I end up getting is NYC. I have a value 23 for large. And then what happens over here, I don't have a value for small, so it fills in, it writes NA, okay? Same thing happens with New York. New York, we have 14 for small, but we don't have a value for large, so we get an NA, okay? London and Beijing fill out and populate correctly, but because of the spelling difference, we end up getting these NAs, all right? And that's fine. Sometimes you don't want NAs, and you can use this argument called values underscore fill, okay? So you can do values underscore fill, and you can say, oh, if you have an NA, put in a 0, okay? Be careful. Make sure it makes sense to say, when I have a missing value, it makes sense to put in 0, or whatever number you are going to use. For whatever reason, people are averse to having missing values. They feel like, oh, if I've got missing values, something is wrong with my data. But perhaps that's just what your data is, and you got to kind of leave it, right? You don't want to assume numbers if it's not true, right? Like if you're recording information about someone and you say, oh, well, how many children does this person have? You don't want to just say, oh, they have 0 children, okay? That's not necessarily correct, okay? Or if you're dealing with patients and you don't have, let's say, you don't know their cholesterol level, you don't want to just fill in some arbitrary number, right? You don't even want to use like, oh, well, the average cholesterol level is this, so let's put that number in, okay? You don't want to, that's dangerous to kind of make up numbers. So make sure it actually makes sense to use whatever fill value you have. Certainly if you put in zeros here and you said, okay, what's the average amount across these cities, that those zeros are going to artificially bring your average down and things like that. So just be careful. Be careful when you fill in numbers. Okay, here's the cities are all spelled correctly, but in this column for size, I have large with all caps letters, okay? And if I do this, again, pivot wider doesn't have any kind of knowledge about what these things are, and it sees different spellings here and says it's going to treat these as different things. And so when it pivot wider, when we run pivot wider, it's going to create different columns for each of the values that it sees in size. So we're going to end up getting a column for all caps large, a column for small, a column for lowercase large, okay? And again, we get NAs for, values that don't exist. So for New York, we have a value for all caps large and small, and a missing for large. And then for London, Beijing, we have the correct values there, okay? So this is how pivot wider works. And all to say, it is important that before you run a pivot operation, you do your data cleanup, okay? And you make sure things are spelled consistently, things are the way they are supposed to look, okay? And we will look at text operations in next week, okay? So we'll look at text operations and how to deal with character strings and doing some text cleanup. So that's coming up, but that is an important thing. And I want to say a little bit more about homework 3 and web scraping and whatnot, okay? There's kind of always this question like, oh, how do I get an internship? How do I, make myself look like a good candidate and things like that? And a good suggestion is like try out these different projects, right? And what kind of projects should you do? And some people will say Kaggle, and Kaggle's a great place to do projects. There's an issue with Kaggle though, is that like competitions, all of the data has already been cleaned up and formatted nicely for you, right? So that removes a big part of like a section of data science, right? So Kaggle is really focused on the data modeling part, which is an important part, but it also doesn't like how did you get the data and stuff like that in the first place is something that you kind of miss out on Kaggle. So another kind of project that you can work on, and this is like it feels a little bit more like grunt work, but it's also very important, is like scraping data or gathering data. And you will see like, okay, if I'm going to try to scrape data from a website, well, first there's all of these like mechanical things that you have to get kind of work with, right? So you can try using Arvest. You might have to learn how to use Selenium or something to kind of get these upgraded browsers. And then you'll also notice that when you scrape data, the data is very dirty and messy and ugly and requires a lot of cleanup. And so, if you are able to, quote, get your hands dirty and handle cleaning up the data and pivot the data and do text cleanup, I think that depending on what kind of jobs you're applying to and what kind of companies you're looking at, that could be a very useful skill set. So, if you're working in some kind of organization where the data already comes in very sanitized and clean, that's not as useful of a skill. In a lot of other places, that kind of skill set is also very useful. So it's stuff to just kind of explore, right? There's like so many different aspects to data science that we can kind of look at. Okay, pivot longer and pivot wider. These are inverse operations. So just to kind of illustrate this, here is the pollution table where we said, it's kind of in the wrong form, so I want to pivot it wider, okay? And we can do that, and I've taken pollution, I've done pivot wider, and I've stored this as table W. But what if I want to turn table W back into pollution? Okay, I can do that, and there are cases where you want the data in this form, where you want amount in the one column and you want size in its own column rather than spread across these two columns. So for example, when you work with ggplot, probably the data might work better in this form. Whereas if you wanted to do comparisons where you wanted to do large minus small, you might want the data in this form, okay? So if you want to kind of undo the operation of pivot wider, you just pivot longer. So I can take that table W and I can say pivot longer. The columns that we want to pivot are the large and small columns. We're going to call that new column size. We're going to call that the value column amount. And here we end up getting back our original table. Okay, and we can then take this and put it into ggplot or whatever. Same kind of thing using the cases table. Here it originally came like this, and we said, oh, let's pivot this longer, and this is what we end up getting. But yeah, what if you wanted to do some kind of thing, and you can say, well, what was the percent change in cases from 2011 to 2012? Well, if you wanted to do something like that, then it is actually useful to have the data in separate columns. So if you have your data in longer form and you want to pivot it wider so you can do kind of these column-wise comparisons, you can do that, right? So you can take pivot longer, you can do pivot wider, and undo the operation, and you get back your original form. So pivot longer and pivot wider, they are inverse operations, and depending on the situation you are in, it might be more useful to have the data in longer form. It actually, in other cases, it could be more useful to have the data in wider form. And I guess just you want to have kind of that flexibility in your head, not to think of the data always in this one structure, but also say, oh, you know what, I can take this data and I can kind of reflow it, or I can pivot it this way or that way, and it's going to serve better in, when I want to do visualizations, it makes more sense to have it this way. If I want to do new calculations of columns and stuff, it makes more sense to do it another way, okay? I need to give you one more view quiz answer. Okay, third view quiz answer today is the letter A as in apple, and that should be your 3 view quiz answers. A as in apple is your third view quiz answer. And we'll go ahead and end here. There's just a little bit more reference reading for you to kind of take a look at. Don't worry about this rectangling stuff, but it is, I guess, a function set and a feature set of the package tidyr. And so in some cases, if you have like web data, especially like JSON data, where it's not uncommon to have a cell that contains an entire list or something, rectangling could be a useful thing there. But we'll avoid that for now, okay? But depending on what you need to do in the future, it could be useful. All right, have a great rest of your Friday. Enjoy your weekend, and we will see you on Monday.